Hello everybody, this is Mr. Harpalani and we are actually starting a brand new chapter today. We did the review and we're all done with factoring for now, and we're starting out with quadratics. This is kind of a long chapter, and you're going to notice that Mr. Hearn, Mr. Bledsoe, and myself are going to split the screencast, so you will get different presenters each day, and we're going to go through this. Now, it's going to be a little different because now this is the new material, right? So instead of walking through the warm-ups, the screencasts are actually going to be going through the notes. So be prepared. They're going to be a little bit longer, but as usual, you can come back and go over material you need to and slow down and all that kind of stuff. So here we go. We're on 9.1 and we are starting out. We've talked a little bit about this, so we're not doing straight lines anymore. We're doing U-shaped curves called parabolas. So the graph of a quadratic is a parabola and is U-shaped. The general form of a quadratic is y equals ax squared plus bx plus c. So totally different than your old y equals mx plus b. This is a new form, and there you have a parabola shown on the right. Okay, so now let's see about these parabolas. So we want to state a, b, and c and state which way the parabola opens up. So remember, a is the number in front of your x squared, b is the number in front of the x, just the number, not the variable, and c is the number by itself. So if we look at number 1, a, b, and c, we see there's not a number in front of the x squared, but that's okay. We'll put a 1 right there. And now we have a is 1, b is negative 5, and c is 9. We can tell if a parabola opens up or down simply by looking at the a term. And I notice the a term here is positive, so that opens up. So let's write that down. If a is positive, the graph opens like this. If a is negative, the graph opens like that. All right, let's look at number 2. So a is negative 4, b is negative 12, and c is 16. So this parabola is going to open down. And number 3, have a fraction there. We can handle that. So a is negative 3/5. B, well, there's no x term, so for the b, we're actually going to call that 0. And c is negative 4. So this opens down because our lead coefficient is negative. Okay, now we have some vocabulary we're going to figure out here. Number 4 asks what a vertex is. So the vertex is either the lowest point on the graph or the highest point on the graph. So if I eyeball this, I'm going to put a dot right about there. Well, that doesn't go through an exact point, so we're going to estimate it. Looks like it's about 1/2, comma, negative 1, 2, 3, 4, a little bit past 4, so negative 4.5. Is that a max or a min? In other words, is that point the bottom of your parabola or is it the top of the parabola? Well, this one actually looks like it's the bottom. And the a term, does this open up or down? Looks like it opens up. So the a term is positive. All right, not too bad. Let's try the next one. You know what? The next one, I'm going to give you 10 seconds to fill out. You try it on your own. Okay, that might help you. I mean, if you're only listening to us talking and not practicing, that's going to be tough. And in class, you know, we do a lot of, we do a problem and then you do a problem, so we're going to try that here as well. So number 6, same thing. I want you to try it and then kind of look and see if you agree. And that is a... All right, so we did those 3. Now we're going to talk a little bit about, well, how do we actually graph a parabola? And so remember, we did a table of values, right, when we did a linear. So same thing, we've created our table of values here, and this says y equals x squared. So if x equals 0 and I square 0, I'm thinking, what's the value of 0 squared? Oh, well, 0 times 0 is just 0, okay? Let's do the next one. What's 1 squared? 1 squared is 1. 2 squared is going to be 4. And you know what? We should try some negative values too. So we're also going to try -1 and -2. Now, if I put -1 and I square it, remember, negative times a negative is a positive 1. If I put a -2 and I square it, negative times a negative is a positive 4. So my table of values looks like this. Okay, so now we're going to go to 0, 0. That's your first ordered pair. 1, 1 is next. And 2, 1, 2, 3, 4 is next. So I've done my first, second, and third ordered pair. Let's now do the negatives. So it's -1, up 1, so right there. -2 and up 4, so right there. Ooh, this kind of looks like we're getting a U, which we expected, right? This is a parabola, not a line. So I'm going to graph this, make it a U, and we're done. So another word we want you to know is vertex. So vertex, actually we already talked about that, right? The bottom or the top of the graph. In this case, your vertex is 0, 0, okay? All right, now let's see what that 2x squared does to it. So this one, we're going to play around a little bit on Desmos and see if we can imagine what it could be. And so if we have your y equals x squared, we already did that, right? And now this time we're going to put a 2 in front of it. So I'm going to turn that off, and I'm going to put the 2 in front of there. And just before I graph it, just kind of ask yourself, what do we think is going to happen? Is it going to be wider? Is it going to be narrow? Is it going to move? And we press it, and remember your original one was y equals x squared, and so that 2 makes it a little bit narrower. So now if I go in, and instead of a 2, remember how we do this sometimes, and we actually put an A there, and remember we make it a slider. So we're going to see what happens now when we shift it. So I'm going to press play. Now look at that red line. Ooh, now it's going negative. So it's getting narrow, 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 goes back up, gets narrow, 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 and you see how it's kind of changing. So going back to our notes, we see that 2x squared, we think that's going to make it narrow, and let's do a quick check. So let's plug in 0. 2 times 0 squared. So order of operations, I do 0 squared first. 2 times 0 is 0. Then I do 2 times 1 squared. 1 times 1 is 1. 1 times 2 is 2. And then we do 2. 2 squared is 4. 4 times 2 is 8. And then same thing, let's do the negatives. So -1, I would get 2, and 2, I would get 8. All right, let's graph it. So here's 0, 0. Here's 1, 2. Here's 2, 4, 6, all the way up to 8. And then it looks like -1, 2, and -2, 8. And just like we expected, as we saw in Desmos, we still have a parabola. It's still going up, but this is a narrow curve, narrower parabola, okay? All right, now we probably won't do all of these, but let's look at 1/2 x squared, and let's go back to Desmos. So what do we think that's going to be? Let's get rid of this. There's our parent function, we call it, so that's your original function. And in terms of 1/2, well, if the other one was narrow, 1/2 is probably a little bit wider. So if we make that fraction even less, what do you think is going to happen? So what if I make it into a 1/5? What if I make it into a 1/10? What if we make it into a 100th? Or 100th? Now your parabola almost looks like a flat line. How come? Because the smaller your fraction, the wider your parabola. So if we go back to here, our 1/2 x squared, is going to be 0 squared, which is 0 times 0, no big deal. 2 squared is going to give you 4. Half of 4 is 2. 4 squared is 16. Half of 16 is 8. And so we get half x squared. We're going to get 0, 0, and 2, 2. And then it went out to 4 up to 5, 6, 7, 8. And you're going to notice you always have symmetry, which is a concept we're talking about tomorrow. So we're going to say this has symmetry over the y-axis. What does that mean? It's a reflection over the y-axis, and we'll talk a little bit more about that tomorrow. Okay, number 4 looks a lot like your basic parabola. The only difference is we are adding 2. So let's see how this works out. I'm going to say y equals 0 squared plus 2. And then I'm going to have y equals 1 squared plus 2. Y equals 2 squared plus 2. So 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. 2 squared is 4, plus 2 is 6. So it looks like I have 0, 2. Then I have 1, 3. And then I have 2, 4, 5, 6. And again, we have symmetry, so it kind of looks like that and like that. What do we notice about that plus 2? Again, we like Desmos to kind of check it out. So we are going to cancel that. And then let's go x squared. Now we said plus 2, right? So plus 2, aha. So did that make it narrow? Did it make it wide? Or did it shift it? In fact, the vertex went from 0, 0 up to 0, 2. So then if I change that and I subtract, let's say down to 6, okay, so then it's going down to negative 6. So back to here. And what do we think about number 5? Y equals negative 2x. Is that a parabola? Remember, parabolas and quadratics have to be squared. So is that squared? No, in fact, that's a linear going through 0, 0 with a negative 2 over 1 slope. So that looks something like that. So that snuck into the parabola unit there. Okay, number 6. Let's plug in our values here. Negative 1/3 times 0 squared plus 3. Negative 1/3 times 3 squared plus 3. Negative 1/3 times 6 squared plus 3. Remember, 0 squared is 0. 0 plus 3 is 3. 3 squared is 9. Negative 1/3 times 9 is negative 3. Negative 3 and 3 is 0. And 6 squared is 36. Negative 1/3 of 36 is negative 12. Negative 12 and 9, or 3 is negative 9. This is going in the opposite direction. So we have 0, 3 right there. Then we have 1, 2, 3, 0. Then we have 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, all the way down here. So this is looking something like that. Remember the symmetry we talked about looks something like that. So this guy's going down. All right, so thanks for hanging in there. Like I said, these are notes, not review or warm-ups, so they're going to be a little bit longer. And look forward to talking with you guys soon. Good luck with your homework tonight, guys. And remember, all 3 of us are available for questions throughout the day. So all you have to do is email or message us through Schoology. Okay? Take care, guys. Bye.